All right. Hello, everyone. Welcome to the IOWN Global Forum Futures event. I hope you've had a good opportunity here at the IOWN Global Forum to do some networking, some learning, some workshops, some education. And before I go on, I just want to give a big round of thanks to the organizers of this event. Every time we do this, it always amazes me at how many people we get engaged in networking. So let's thank the organizers for all their help and all their efforts. Thank you very much. All right, I want to keep the energy high in the room because we have so much ground to cover. We have a lot of fantastic experts speaking with some great and relevant content. First, a little background on the reason for this event. We have this event in order to both educate our own members about some of the things that are happening in the IOWN Global Forum, as well as some of the new technologies and ideas that are coming out of the IOWN Global Forum. But we've also opened this up to the public because we want to share this with more people to create awareness, understanding of what the IOWN Global Forum is about, what we're trying to achieve with photonics-based networking and computing, very important to the future of technologies and to society. So having said that, we make sure that we recruit a good range of speakers for this event. And again, it's open to the public. It's also being live streamed, so it's available online. And the speakers are coming from a wide range of partners and members of the IOWN Global Forum. I want to go briefly through the agenda just so you have a sense for what it is, and then I'm going to bring up our opening remarks. So we're going to have a number of sessions. The first one is going to be presenting what does the IOWN Global Forum organization look like? What are some of the resources? What are some of the deliverables? And that'll be delivered by Gonzalo Camarillo, and he'll talk about the IOWN Global Forum's organization. Then we're going to have Ito-san from the Sony Corporation, who leads the use case working group as chair of that group, and he'll talk about some of the activities and results that they've had. And Kawashima-san from NTT Corporation, who leads the technology work group, and he'll talk about some of their results. And then we'll have a guest speaker from Omdia, a leading global market research company, Ian Redpath, and he'll give us a market landscape for what is happening in the photonics markets and some of the changes that are coming and some of the needs that the IOWN Global Forum is helping to address. So we're very happy to have him here. So around 3:10, we'll have a break for about 20 minutes. And then when we come back, we'll have two panels. The first one will be on driving energy efficiency and sustainability, led by Lieven Levroux, as you can see here. And the second one will be around delivering tomorrow's infrastructure, an industry perspective, led by Supantha Mukherjee. So at the end of that, we're trying to target to end at around 4:25, 4:30, and we'll have a networking event outside for all of you to join us. So I want to kick off the afternoon by inviting to the stage Eric Hardwin from Orange. Please come up and give us some opening remarks.
Thank you, Vido. Hello, everyone, and welcome on my behalf and on behalf of the whole IOWN Global Forum to this Futures event. So my name is Eric Hardwin. I'm from Orange, where I have the chance to lead the research on future networks design. And I'm also a member of the board of directors of the IOWN Global Forum. So that you understand where I come from, I'd just like to remind that Orange is a network operator and a digital service provider. We are headquartered in France, but we operate in 26 countries in Europe, Middle East, and Africa, serving a little bit less than 300 million customers. And I will not go over the details about everything we do, but we do operate mobile networks, fixed networks, and also, from access to submarine cables around the globe. So with this, I'd like to kick off with our views of the challenge that are in front of us in the 2030s and beyond. And the first one is, I would say, usual. One of the main challenges that we face as an operator is that we need to constantly upgrade our infrastructure because the traffic that we serve is constantly growing. And this chart is extracted from the Nokia Bell Labs Global Network Traffic Report that says that it is expecting that the traffic between 2023 and 2033 will grow by between 5 times and 9 times. And this is huge. And of course, this costs a lot of money. You may have seen on my previous slide that Orange invests about 5 billion euros per year on the networks on all our geographies. So this is really a lot of money. So how to absorb this traffic with a reasonable investment is, I would say, the historical challenge of operators. Since a few years, there is another dimension that has appeared in our industry. It is the importance of becoming net zero in the global effort towards sustainability. And in Orange, but other operators and equipment providers have taken similar commitments. We have taken the commitment of being net zero by 2040. And you can see that reducing our CO2 emissions is extremely challenging when at the same time we need to continuously upgrade our infrastructure to absorb the growing traffic. And that was the situation, I would say, up to last year. And then there is something new which has appeared that makes it even more challenging. It is the impact of AI, and particularly generative AI. And here I'd like to share this figure from the International Energy Agency, from an excellent report that was published a few days ago, actually, that shows some predictions about the energy increase due to AI by 2030. And you can see that there are various curves, and the reason is that this report elaborates on various sources, and there are very different views on what will be the impact of AI in terms of energy consumption. But at the minimum, it will be very important. At the maximum, it will be crazy. And it's more or less the same for the impact on the networks. It's very uncertain at the moment what will be the real impact of AI on the networks, at least in terms of AI services. So this altogether makes it very challenging for us operators in terms of investment, but also in terms of respecting our commitments towards being net zero. And there will be a panel where we will discuss this in more details later in this afternoon. So with this, the Orange views on what we expect for the future networks, whether they are mobile or fixed, is very aligned with those challenges. First, we want our networks to improve the performance so that we can at an acceptable cost, manage the traffic increase. We want also any future technology to help us to meet our trajectory towards being net zero at 2040. But sustainability is not only the environmental impact, it's also the social and economic impact. And when we talk about social impact, what we see as extremely important is the trust. We want our customers to trust our networks. So that means that our networks, they need to be secured. They need to be always working, so in case of failure, which we want to minimize, of course, but we need the network to be able to go back online very fast to maintain the service. As part of the sustainability, we often think of sustainability as being about energy consumption, and energy consumption is a major dimension of sustainability, but that's not the only one. You know that any hardware that we deploy has also some embedded CO2 inside, which comes from the production of the hardware, its transport on the site where it will be installed, and the end of the life, when we remove it from the network, dismantle it and recycle it, hopefully. And we need to take all those emissions along the life cycle of the equipment into account when we talk of sustainability. So one way to also reduce our CO2 emissions is to extend the lifetime of our equipments. And with this, we have the stake of being able to reuse as much as possible of our infrastructure. One very good example of that is the fiber. We have invested billions of euros in deploying fiber networks. We don't want to change our fiber, not before a very long time. And of course, that means that when we are upgrading our fixed network, we want to change only the endpoints, not the fiber itself. Then we have also new technical disruptions coming up. AI, of course, that will be very helpful to automate the network, but also the cloud-native revolution that we believe has also the potential of helping us reducing our costs and also reducing the amount of equipment that we need to install due to the mutualization benefits of it. And at last, and this is something that we have heard a lot this week during the IOWN Global Forum, and I'm very happy about it, we want to bring value for society. because there's no need for technology if it's useless, because no one will use it, no one will pay for it, so we will not reimburse our investment, and we will totally defeat our purpose. So when it comes about technology, value is, I would say, the centerpiece of the motivation for new technology. We are strongly convinced that we should not have new technologies just because we can improve the data rate from a technical perspective. We should do it only if, in the end, we can identify some benefits for the end users out of those increased data rates or reduced latency. And identifying the value is very important to drive, then, where we want technology to go. So, with this, why are we here all together in the IOWN Global Forum? Well, it's to address all those challenges. And I will not speak maybe for all the other members, I will speak for Orange. Orange was very happy when the IOWN Global Forum was launched because the goals of the forum are very well aligned with the challenges that we identify. And with what we have shown on one of my first slides with this AI explosion, it's even more relevant today as it was, I would say, when it was launched. And I will not go along the details of what we do from a technical perspective because there will be presentations about that later this afternoon. But I would like just to give our view on what makes IOWN really stand out compared to other forums. What are its really key features that we believe make it relevant for addressing those challenges. The first one is that it addresses networking and computing in a holistic manner, not one and the other. Those two very essential dimensions of our digital world all together. And that allows for optimization. And that is one of the reasons why we believe that we can reach those very ambitious targets which are shown on the screen. The other strong benefit of the forum is that it brings together all the stakeholders in the value chain, technologists, equipment vendors, operators, but also end users that are able to confirm the value I was referring to before. Then we don't work only on the technology part. We work on identifying use cases, designing technology proposals, of course, but also identifying some reference designs and making proofs of concept to prove that what we do, what we think is actually working. And we are also considering proof of values and proof of business, which connect to the value and the economic sustainability. Because in the end, and that's a very important difference between research and technology. In research, we want to push the limits. In technology, we want to build something that will bring value at an effective cost point. Because in the end, someone will need to pay to develop the technology, deploy the networks, so there is the need for having a total virtuous cycle where the money comes in and out in equal manners. And at last, we also are not close to ourselves. We collaborate with the various organizations that are standardizing the technologies because IOWN is one part of the very vast ecosystem where we're all together. So with this, that was our perspective, why we think it's the IOWN Global Forum action is very important. That is why we are here. And if you share those concerns and you're not yet a member of the IOWN Global Forum, please join us. So with this, I wish you a very nice event, and I will stop here. Thank you.
Oh, thank you. Thank you very much, Eric, for setting the stage and the challenges and the opportunities for this group. Next, I'd like to announce the next speaker, the very famous Dr. Gonzalo Camarillo. I call him very famous because he is in our group and is a strong leader for the IOWN Global Forum. And we are in Stockholm, Sweden, so thank you to Ericsson for being our host country. So Gonzalo, please, your stage is yours.
Don't escape. Yeah, I was telling Vito not to escape. Okay, good. Thank you. Yeah, I mean, as Vito said, we are extremely happy as Ericsson to be hosting this meeting Ericsson's headquarters are in Stockholm. So I'm hoping, you are enjoying the meeting, the sessions, and you have a rest of productive day. But here, I'm not to talk about Ericsson. I'm here to introduce the forum. And basically, as Vito said this morning, when we were designing this Futures event, this was originally expected to be also useful for members, but also for non-members. So in a sense, I need to be kind of covering something that is useful for members, but at the same time, it should be an introduction to the forum for non-members to get familiar with that. So I will try to compensate that and talk about what the forum is, but stress also what we are changing and what we are changing in order to tackle the future challenges. So it's useful, hopefully, for both members and non-members. So if we go to the next slide, please. Yes. So this slide Eric just showed, those were the 3 pillars when the IOWN Global Forum was formed, and that's already 5 years ago. As you know, we are celebrating the 5th anniversary. If you haven't checked the chocolates that we have there with the logo, please do that. They are great. So we had these three pillars, which is lower power consumption, higher transmission capacity, and lower end-to-end latency. So those were the promises we were making. And there, up there, you have basically the original mission we had, which was to build the communication infrastructure for the future and lead the transition from electronics to photonics, which has been the theme all the time. We are trying to basically go from electronics to photonics in order to get all these 3 pillars and the advantages of that. The effort, it has certain properties, and is data-driven in the sense that we are actually, and basically, Eric was showing the curves. We have similar curves for capacity, data capacity that is going to be needed on the internet. So we need the IOWN Global Forum technologies to tackle that, and that's what we are trying to do with our technologies. It needs to be secure and resilient. That's obvious. And resiliency, actually, with the geopolitical situation, we had basically a speaker in the open plenary, basically painting a landscape of the geopolitics today. Resiliency is getting even more important than before. And actually, this is a good connection with Eric's point about the fact that now AI is coming here, is needing a lot of bandwidth, and we were working already on meeting those demands even before they existed. This is something similar. We were working on resilient networks and improving the reliability before the situation actually required it. So we are happy to be paving the way into the future and basically getting to address some of the new requirements that they appear as we go by. Sustainability, it's, again, as Eric was describing, not only about lower energy consumption, but about much more. And we will have a panel right after this. So, well, after the break, I think. So, yeah, it's right after the break. So you will be able to basically get, the approach of the forum to sustainability. And finally, a global effort. In order to do all this, we need a global effort. We need players from all around the world, and we need basically to get industry alignment, which is global. This is not about one country or even one region. It's about the world. And that's why we have members from many different geographies here. So if we go to the next slide. There's a lag there. But yeah, so one question I always get from journalists is what makes the IOWN Global Forum unique? So what is the property that makes the IOWN Global Forum the right forum to standardize, or more than standardize, to build the future in this area? And I always say it's like 2 things: the ways of working and the diverse membership we have. So if we start with diverse membership, because I was tackling there at the last slide, we have companies that they are very diverse in many different dimensions. Here I have 3 of them. So we are covering user companies, research institutions, equipment vendors, operators. So if you have in any use case the whole value chain, we have stakeholders from every single part of the value chain present in the forum and providing their input. That's extremely powerful to develop these technologies. The second one is industry verticals. As you will know, we have several use cases. So in order to address an industry vertical, you need the companies there. And in that sense, we have companies belonging to many different industry verticals. So that allows us also to cover many different use cases, which is key and is fundamental. And that makes the IOWN Global Forum actually quite unique as well. And the market areas, I already covered that. We need a global effort from different geographies. It's not just about one region. And we actually do have members from, all the regions. We have, at this point, 162 members, so it's a large number of members. But more importantly is the ways of working, and this is what I was introducing before, that I want to talk about how we are changing the ways of working in order to tackle our challenges. So the way we work is like we define a use case. Let's say we want to do remote video production. That's one of our early adoption use cases. We start with defining the use case, and we define the use case with the companies involved there, what we call user companies. Once we have defined a use case, we extract the requirements, the technical requirements from that use case. What do we need technology to do in order to support and implement that use case? Once we do that, we basically develop the blueprints, technical architectures, concepts, etc., that they are needed technically to meet those requirements. And then we go and prototype them. This is an iterative circle, so we have proof of concept prototypes, we learn, we go back to the drawing board, and we improve the technology. This has been what I've been presenting so far in the last 2-3 years, and this is where we've been looking at the processes, because one important thing from the IOWN Global Forum is that we have the right processes, the right governance, the right members, in order to tackle the challenges we have. And one thing we saw, and that goes to what the goal is, Eric was presenting this, that is not only having technology, but this technology that is creating value at the right price level. We noticed that we were not doing enough. So we are changing the way we actually assess the technology and the solutions we put together with a framework that consists of 3 steps. The first one is the proof of concept prototypes. We are building the technology to make sure that the technology works. The second one is the proof of value. So we are actually checking that the technology we are developing works, because we have a proof of concept. It creates the value to the stakeholders we said it would. It needs to create the value to all the stakeholders, and that's what is fundamental from the IOWN Global Forum, that we have all the players in the value chain. Not only that, once we confirm that we have technology that works, that is creating the value, we confirm the economic viability, but doing a proof of business, which is the last proof we do. So proof of concept, proof of value, proof of business. At that point, we know that we have technology that works, that creates value for the stakeholders at the right price level, so that we can have a healthy ecosystem and is business viable. To be clear, let's say that we had a technology that works, we are reducing the delay as we said we would, so we are creating value, but it would be doubling the cost of a network. That's probably something that we are creating value, but is not economically viable. So just to keep in mind why we need the 3 of them. We are quite excited, and Ito-san and Kawashima-san will come after me, so they will be talking about this. I don't want to steal their thunder, so I'll stop talking about this framework, but just keep in mind the framework, because it's a fundamental piece of IOWN Global Forum. Proof of concept, proof of value, proof of business. And then lastly, let me talk about the use cases. As I mentioned, we work in terms of use cases, and we have defined so far 3 vertical use cases, early adoption use cases. We use Jeffrey Moore technology adoption lifecycle in order to define the market penetration we have, and now we are in the early adopters curve. And regarding early adoption use cases, we are working on those ones: video production, connecting financial institutions, and remote GPUs. And then those are, again, vertical use cases. We have a horizontal use case, which is the mobile front haul. Mobile front haul, it basically is about 5G and 6G, how you transport, you implement the transport on those networks. So that's more a horizontal use case. In addition, we are exploring adding new use cases, and I can mention that one of them we were looking into is remote tunnel building. But again, Ito-san and Kawashima-san may be expanding on those in their presentation. I see they are both on the first row. And again, not to steal your thunder, just to mention, here. If we go to the next slide. Yeah, and this is how we are organized, actually. So we have 3 different steering committees, and this mirrors the ways of working that I have described before. So we have the market steering committee. I myself am chairing that, and this is the idea of this committee, is to promote the IOWN Global Forum, to explain to members, to non-members. So that's what we do. But then we have the vision steering committee and the technology steering committee. And as you can see, the use cases, defining the use cases, it comes from the vision steering committee, and then all the technology work it would come from the Technology Steering Committee. And we will have Ito-san and Kawashima-san representing both steering committees respectively in the next presentation. And I think that was my last slide. So again, just so that it's clear, we have a set of unique properties in the forum that makes it actually quite interesting, and it makes it quite likely to succeed in defining this type of networks for the future. Again, the forum is special because of the diversity of the membership, the governance we have, and the processes we have, and the way in which we actually make sure and we assess the technologies in terms of, again, proof of concept, proof of value, and proof of business. And having said that, I think, this should serve as an introduction to the next presentations you're going to see, like Ito-san and Kawashima-san, and then we will have the two panels. So I hope they complement the information you got so far from Eric on the vision and challenges, and from me on the introduction, so that, as a whole, it's a useful future session. With that said, I will give the floor back to Vito. Thank you very much.
Thank you so much, Gonzalo. Yes, now we'll have our next speakers. We'll start, I believe, with Ito-san from Sony Corporation, if you want to come on up. And he is the chair of the use case working group. Come on up.
Okay, thank you very much for the introduction. I'm Katsutoshi Ito, the use case working group chair, and I'm also representing the Sony Corporation. We have been talking about this 5th anniversary of the IOWN Global Forum, and I'm just grateful that for having had the opportunity to serve as the use case working group chair since its establishment of the IOWN Global Forum. It has been a very great journey so far. So today, I am going to start off with this question to take you back 5 years. What were you doing 5 years ago? Take a moment to reflect on this. The year 2020, this was a time when everything has changed. The way we work, the way we spend the time, and pretty much everything in life has changed. What was ordinary, what was normal, did not come easy. And we had to adapt to the new circumstances. And this is how we got started as IOWN Global Forum. We called ourselves an online native forum. From day one, it was WebEx meeting. Team building was a challenge in the early phase. Many of you were able to see my face through the camera, but unfortunately, I was not able to see most of the attendees. I get the name, I get the expertise, but I was not able to connect the person. And then, it wasn't until year 2022, we finally was able to have the face-to-face working group meeting. But even back then, wearing masks, which made it difficult to see full expression of the members, and hindering the conversation, making it challenging to gauge emotions and reactions in accurate manner. Now, despite starting off with unfavorable circumstances, I'm very proud of the things that we have been able to achieve so far. In the first 5 years of IOWN Global Forum, at least 4 key achievements were made. First being the vision formation and engagement among the diverse members. At least 100 members were attending each of the monthly working group meetings. We had held that for 5 years. 100 members are always attending on this meeting. Second being we have successfully set requirements and evaluation criteria for technology side to work on. We have defined 22 use cases addressing various industry challenge and need. Third, we have provided 17 reference implementation model and POC verifying the potential and validity of the IOWN technologies. And last, for fourth, being we have now started to prepare more business proposition aspect for some of the use case and technologies. And let me highlight on that last part of the achievement, that is the activities targeting toward the business propositions. Within the IOWN Global Forum, we have been working on 2 tracks of the use cases. First track is the use case targeted beyond 2030. We call these future-looking use cases. Having these use cases provides requirements and rationale for the technology development. Then, as the second track, we took a look at the IOWN technologies component that can be ready in short term. Using these technologies, we have formed early adoption use cases, which we are focusing on targeting to go-to market and with this solid value propositions and the business case. The foundation of technologies for the early adoption use case is the All Photonic Network, APN, which is characterized by the high capacity, ultra-low latency, and deterministic latency, dynamic path allocation, allowing the time sharing of the resource among users, and disaggregated network components, allowing to reduce both CAPEX and OPEX for the network operators. With APN as the foundation technologies, we have defined 4 early adoption use cases. Gonzalo mentioned 3, but we have 1 additional coming. Distributed service infrastructure targeted for the financial industry, remote live media production targeted for the broadcast industry, remote GPU targeted for the use of the AI, and remote tunnel construction use case. Our methodology or the process to make these use cases available to the market at an IOWN Global Forum is first make a use case document clarifying the value proposition. What is good for? We're not talking about technology. What is good for if this technology is available? Second, making a reference implementation model for the member inside and outside of the IOWN Global Forum to conduct proof of concept, POC. And after we execute the POC, compiling the POC result to validate our value proposition, formulating into even more compelling propositions. For the first 3 use cases, which are the ones that Gonzalo was referring, value proposition documents, call for POC documents are now completed, and it is open for the public. And members of the IOWN Global Forum is now in the stage of conducting POC. So we are expecting to have some of the results already within this year. Okay, although we call them POC, our aim is to go beyond technology proof. Our aim is to make the proof on customer value proposition, as being talked about with Eric and also the Gonzalo, make proof on the business case, addressing economical rationale for the adapting IOWN technologies to the stakeholders. For the service infrastructure for the finance industry, we will soon be conducting POC, demonstrating the virtual machine live migration over the 2 data centers separated over 70 kilometers distance, allowing to provide performance, scalability, and resiliency to the highly regulated and also the mission-critical finance industry needs. For the remote live production, we are now in the phase of to do the pre-commercial level trials. We are now planning to use the APN to enable remote live media production in the 2025 World Track and Field event, which is coming on September. And for remote GPU, we will be verifying on-demand GPU validity by looking into GPU utilization, energy power consumption, and total cost of ownership, and having its result also within 2025. So now, looking ahead to the next 5 years, we will continue striving to make the vision into a reality. As mentioned, we are moving beyond proof of concept to proof of value and proof of business in an effort to accelerate the social deployment of IOWN technologies. And we will focus more on the use cases that addresses the global market. And to do that, since I believe the process we implemented for the early adoption use cases were very successful and effective, we intend to expand these early adoption use cases to address the wider range of the stakeholders. So, expansion of the early adoption use case. This is twofold, expanding the vertical industry use cases. Again, this was explained by the Gonzalo. We have diverse membership. We have multiple vertical players here, stakeholders here, so we are confident that we'll be able to do that. Then we will be expanding toward the more service platform or the infrastructure type use case, addressing both fixed and mobile network operators. And by doing so, we are quite confident that we'll be able to reach out toward more global segment outside of Japan and Taiwan. I think we are already moving forward in Japan, Taiwan, but now the new focus will be outside of this region. So, and also in order to make our proposition more compelling for the business proposition, we are going to apply what is called techno-economic analysis concept to validate economical rationale or the business rationale. We are now trying to formulate the framework and hope that we'll be able to apply and share some of the results from the early adoption use cases, solidifying our technology offering and the propositions. Okay, again, the important message here is to go beyond POC. We will be stepping into proof of value and proof of business aspect in the next phase of IOWN Global Forum activities. Okay, I have started off with the question with what were you doing 5 years ago? And I am going to close the session with the question, what will you be doing in the next 5 years? I am hoping that everybody be with us with IOWN Global Forum, driving innovation and making things happen. Okay, thank you very much.
Okay, then following Ito-san, I would like to introduce our technical working group activities. So could you change the slide? Yep, okay. So first, I'd like to start with this slide. So this slide explains why we need new technologies. So Ito-san introduced early adoption use cases such as financial service institute use case or remote video production and AI. But with today's technologies, we cannot implement these use cases. The reason why is there are a lot of technology development, but while cloud service providers' infrastructure keep evolving, the infrastructure on WAN and customers' premises, sometimes we call edges, are not evolving at the same speed. So basically, the bandwidth or efficiency gap between clouds and the rest of the world is widening. So that's why we do not believe that we cannot implement these early adoption use cases with today's one. And one of the reasons for this bandwidth gap, efficiency gap, is lies in this WAN. Today's WAN is based on optical transport system, which is operated with mostly static fiber topology. That's the problem. That's why we have defined new network called open or photonic network. So this open APN will enable us to expand optical transport with enhanced agility. And with this one, basically, we can connect customers' premises, edges, to cloud with agility. And with this architecture, we will be able to implement these use cases with enough performance and with enough latency feature. So let me explain what is Open APN. So basically, what you see in the bottom is these two methods shown on the bottom show today's networking method. So we sometimes use dark fibers. If dark fibers are not available, we use carriers Ethernet list line, and this here on this slide, that's list line called today's wavelength service. In these cases, we use a packet optical transport system, and this packet optical transport system is deployed at carriers' local offices. But it's not this, because this is a large system like express railway station, so it cannot be deployed to many carriers' local offices. Basically, this can be deployed to large carriers' offices. On the other hand, in APN, we disaggregate this packet optical transport system into 3 tiers: transceiver and APN-G, which is a more multiplex, demultiplex node, and APN-I, this is exchange node. So we disaggregate today's transport system into 3 tiers. And with this disaggregated architecture, we will be able to expand our optical transport infrastructure with enhanced agility. So this slide shows the difference between today's optical transport system and our IOWN APN. So as you see, with today's ROADM system, basically this transport system can be deployed to a large carrier station like express railway station. On the other hand, as you see on the right side, with IOWN APN, we can deploy optical transport node to many local stations like metro stations. So with this, basically, we can optical transport infrastructure can achieve dense area coverage, supporting agile area expansion. With this, we'll be able to connect many customers' premises, edge sites to cloud with enhanced agility and enough performance. And in addition to area coverage and agility for area expansion, one difference, another big impact on telecom infrastructure with IOWN APN is economics. So as you see, in today's deployment model, basically carriers have to invest in transponders. Transponder is the most expensive infrastructure element, and we have to invest in transponders. On the other hand, in IOWN APN, transponders and transceivers can be deployed to customers' premises and can be recognized as revenue-linked expense. So it doesn't have to be recognized as infrastructure capex. So with this, basically, the carriers will be asset light. So this will be a huge impact on carriers' business structure. And let me explain the relationship with our work and other consortia's work. Of course, there are a lot of consortia who are working on optical technologies. And we are not working on the specific optical layer technology. Actually, because we know that there are a lot of other consortia that are trying to develop new optical transceiver specifications and so on. So basically, our position is to make use of such other consortia's work. And we basically add new unique values by defining a new deployment models that would create more impact, as I showed in the previous slide. So as our activity raises the value of their works, they work very collaboratively with us. Another uniqueness of our activity is that we are not just working on network layer. we are also working on computing stack, and also we are working on data sharing technologies. Because we know just upgrading optical transport is not enough to enable future applications. As you see, even if we upgrade the network with high-speed network like APN, actually in customer premises, there are many security gateways and also TCP/IP network, Ethernet, and so on. And in customer campuses, typical situation is that many packet switches are very old generations. So even if we deploy IOWN APN inside the campus, inside customer campus, there are a lot of switches working on 1 gigabps transceivers. And also, on top of Ethernet, the computing stack will be we try to transfer data with TCP/IP, so it is very slow and energy consuming. And also, lastly, even if we have high-speed computing infrastructure, one of the issues is data privacy. Typically, enterprises do not want to expose their storage array to computing node outside of their campus. So we have to re-architect the total system so that we can leverage the high-speed, low-latency nature of open APN. So this is our unique activity. So we work on computing stack and also in data space layer. And also we are working on sensing technologies such as fiber sensing. And of course, security is very important. We cannot change the infrastructure without reworking security mechanism. So the forum is redefining full stack and end-to-end network and compute infrastructure to streamline data transferring and data processing at light speed. This is what we do. And this is a good one example of our edge cloud computing with IOWN Global Forum technology stack. So at the bottom, at the bottom we have Open APN, and then this Open APN will provide secure software-defined optical transport with DWDM wavelength path. And we're gonna have, on top of that, we have Open APN-based determinist network, and that network will provide Ethernet virtual connection with determinist QoS for NIC to NIC data transfer. And on top of that, we have IONSEC. This is a new security mechanism to assure the security to protect customers' environment and the computing space users' data. And then we have DCI cluster, which allows us to transfer and process the data at the speed of optical communication. So this is a good example. So with this full stack architecture, we can connect customers' edges with cloud computing resources without losing performance or efficiency. So maybe you think that this is technically possible, but how could we get the critical mass in the market? Critical mass in the market. Being innovative often means being too risky for many people. So important point is we collaborate at this forum in IOWN Global Forum way. This is echoing what Gonzalo said and what Ito-san said. So we start use cases and we develop subsystems and we develop reference systems and we do POC. And lastly, we quantify the economic and environmental gains from our solution. So this is what we call techno-economic analysis. And lastly, we market the developed solutions with convincing data. So with this unique way, we believe that we can do this. We can make our innovative solutions accepted in many regions in the world. Okay, so the key takeaways from my presentation is today's one cannot achieve high bandwidth and high agility at one time. So this causes the bandwidth efficiency gap between the cloud and the rest of the world. So IOWN Global Forum Open APN solved this issue by achieving the dense and agile coverage of optical transport. But just upgrading optical transport is not enough, because today's systems are designed to work best with best effort packet networks. So the forum is developing full stack end-to-end compute network infrastructure to streamline data transferring and processing at the speed of light. Our vision may sound too innovative, too ambitious, too risky, but we believe it's worth the challenge. And we can do it with the IOWN Global Forum way. That concludes my presentation. Thank you.
Thank you, Ito-san and Kawashima-san, for identifying the challenges and opportunities, as well as the solutions that the IOWN Global Forum is working on. And thank you for your leadership here at the IOWN Global Forum and your expertise. Well, to add to that discussion about challenges and opportunities, we have a special guest here, Ian Redpath from Omdia Research, and he is here to give us a market landscape and give us additional insights into the needs and challenges and opportunities for photonics-based networking and computing, mainly focused on networking. But I'll turn it over to Ian and take it away. Thanks.
Thank you, Vito. Okay, well, yeah, I'm from Omdia. For those that are not familiar with Omdia, an analyst research firm, global, with our HQ in London, and my primary area of coverage is optical networks. So in terms of a talk today, and as Gonzalo mentioned, in his talk, we are kind of looking at a two-track. We've got some messages in here for the non-member part of the community, but don't worry, there'll be lots in here for the members as well. So I'm going to cover a little bit on some optical network fundamentals. What is the role and the scope and some of the pressures that we're seeing on the optical networks? Look at some of the next generation requirements and how we're going to get to the all photonics network. And then how does this impact the stakeholder community, consumers, enterprises, and even governments? And then move on to an evolution of all optical networks and technology enablers and challenges. So, for the non-member community, what is the optical network? And we've already discussed some of the fundamentals, but just kind of running through some of this quite quickly, taking it right down to its essence, it's about the transponders that have been mentioned already. And in the transponders, there is a laser, and then there's electronics to control the laser, and then the digital information is encoded on the light. So we have the transponders, and then we have the fiber infrastructure itself. So, what does this all do? It really transmits light and via the fiber optic cable at tremendous bandwidth levels. We'll hear all kinds of numbers, gigabits, terabits, petabits. There was exabits on our chart. It's huge volumes of light, very efficient, responsive, and low latency. And so what is the value? It really underpins the entire digital economy of the world. And with the all photonics network, it is going to take us from where we are today into the future, enabling future applications. And then my graphics on the bottom are just to give you a little bit of a sense of scope of the optical networks. So we do have edge, and we have middle mile. Then we have national, and we have international. So we do have pan-European networks that cover the entire continent. And then subsea is a critical part as well. Crossing the Baltic, crossing the Atlantic, and connecting the entire globe. So the scope of the entire optical layer is nothing short of global. And here's a little bit of a view of network architectures and how do we get from our devices to where all the applications are sitting. Many of the applications are sitting in data center infrastructure, and we've got a number of access mechanisms. There's the mobile side. The little bit that's a little less kind of widely publicized on the mobile side is once you reach the tower, modern networks quickly convert to the optical layer at that point. And then we have our home networks where we do have optical potentially right into the home. If you don't have a fiber right into your home, it's probably pretty close to your neighborhood. And then enterprises, you know, and thinking a little bit more about the larger enterprise sites, the HQs, the campuses, we've seen, you know, a transition from 1 gig to 10 gig, and now for larger enterprise sites, folks are talking a lot about 100 gig as an entry point into the network. So it's all about connecting people and enterprises and the compute applications. And so what are the pressures on the optical core? And really, there's a lot. So the biggest one, and the one that's in front of us right now, is all about AI. It's really the here and now driver. AI has been with us for a while, but it's really elevated over the last little while. And just to give you a sense of the timing, we track the optical network market, so part of that is all the optical equipment shipments, and the shipments are what goes to the carrier community, and they deploy. So the AI phenom has not hit the WAN just yet, but it's coming, and we're seeing many interesting precursor data points. You know, everybody's tracking the news. The first thing is, you know, tremendous data center upgrades. So we're really into a major infrastructure build cycle. So just to cite one data point, the Meta announcement of building a $10 billion campus. For those that don't track the data center market constantly, we've had a lot of billion-dollar sites built, and sometimes if a location is, you know, been in upgrade for a number of years, and could get to about 2.5 billion, but they announced a 10 billion right out of the gate. And so that's gonna have a huge impact on the bandwidth as we go forward. So some other quite interesting indicators that we're tracking at Omdia, we look a lot at what goes into the data centers. So we're tracking GPU shipments. You know, that's a big news item. That's up, obviously. We also track the optics that are inside data centers, and this is a huge hot topic at OFC. We're transitioning from a 400 gig to an 800 gig speed inside the data center. So the short reach, the 300 meter, the 500 meter, the 2 kilometer, that's ticking up. And then other parts of the ecosystem are tracking up as well. So the actual companies that produce the fiber, companies like Sumitomo, OFS Furukawa, Corning. Corning has cited that their fiber shipments are up. So these are quite all interesting precursors, and we're just really waiting for the shoe to drop to see when this starts to impact the optical market in a big way. Meanwhile, everything else that had been going on for the last number of years is still there. You know, one of the earlier talks, cloud service was mentioned. That's become a $300 billion business, and it has shaped the optical network and grown the optical network in and of itself. A lot of CapEx has gone into there. Enterprise access, I mentioned getting to 100 gig. Every generation of mobile adds to the bandwidth requirement on the optical core. So as we go from 5G, 5G advanced, 6G, more pressure, and then as we move through the residential side. And then also touched on earlier, geopolitics and sovereignty. So we're starting to see this have a meaningful impact on route builds. So there are a number of choke points around the world, and we're finally getting to an environment where we're seeing some earnest developments in pushing forward with some new and innovative routes, and we're going to see more and more of this. So, you know, another quite interesting point that I find is, you know, moving back into this fiber infrastructure build era, that's ongoing. So we're hearing a lot about diversity, and when you think about the capacity that's needed here, you know, there could be fiber routes existing, but a third route is being built, you know, across the road. So it's adding capacity and it's diverse. We're hearing a lot more about tethering, and this ties a little bit to the power part of the equation. Many locations are getting tapped out on power, even Northern Virginia. And so we're starting to see offload, and we're starting to see fiber being built to help that type of offload. So there's a lot of, it's really once in a decade or once in a generation, this phenomena that's hit us now. And for everyone in the optical sector, it's quite an exciting time to be part of it. So what does this mean in terms of next generation requirements? And I think these are all quite familiar to the membership community, but greater bandwidth and enhanced optical capillarity. So just to double click on that a little bit, it's really about, you know, extending more and more to the edge. And we just, we just saw that. Yeah, that's, it's absolutely ongoing for sure. Lower latency, obviously key. You know, how do we get there? And one of the avenues is network architecture simplification. If you take the electronic steps out of it, if you minimize the OEO, then that's one avenue to reducing latency. But there's many levers that you can pull to reduce latency. The actual fiber routes selected, and we're seeing quite a bit of that with new bisectors. Power consumption, obviously a key IOWN initiative. And then this has come up as well, cloud-like agility. So what I mean by that is, you know, people have gotten quite used to cloud services. When you need, you know, processing, turn it on when you need it, turn it off when you don't need it, and only pay for when you need it. Well, people do like that model, and they'd like to see that brought into the bandwidth world as well. So having a more dynamic environment for accessing bandwidth, turning it on, and taking it down when we don't need it. And then security is obviously a key, and there's a number of things going on in this area as well. Fiber does have the benefit of, it is inherently hard to intercept photons, but we do have encryption techniques on top of it, and we also have some quite good innovations in terms of distributing keys to manage the encryption, and there's some solutions out there in the market. So a lot of what we have here in terms of the requirements that we're seeing align exactly to the forum's goals. So we do have a good alignment there. And so casting back a little bit and then looking to where we are now, you know, for implementing the all photonics network. You know, if we look back a little while ago and then to now, you know, we have seen a number of change. So we think about transponders, you know, everyone knows a few years ago, they were rather large, and now we've gotten to much smaller pluggables, much smaller form factors, QSFP-DD, QSFP-28, these are quite small devices. And what that enables you to do is slot those into more locations, and more locations that, you know, previously didn't exist. So we've started to create a category that we call multi-host, and multi-host could quickly mean router, but even network elements beyond a router can accommodate some of these pluggables. So we went with a broader multi-host term. And then in terms of reach performance, the early generations of pluggables were a little bit more reach limited. Now we're just on the cusp of some quite impressive pluggables that will reach into the thousands of kilometers. So it'll effectively cover the European continent. Looking back, we had a number of pictures on ROADMs. So ROADMs, you know, historically were really for more in the core, and by focusing on cost-optimized edge ROADMs, taking cost out, simplifying the functionality for the edge need, we have this now, cost-optimized optical terminals. So it's another tool in the toolkit. Another area where there's been quite a bit of advancement, and we also saw a bit of that is around wavelength switching, and we're moving to you know, more advanced and effective wavelength switching. And wavelength switching has even become a topic inside the data center, which is quite interesting. And what's really elevated it from kind of an idea to closer to reality is AI. There's some reasons why AI pushes the desire for optical switching inside data centers. And then, the whole idea of multi-layer, this has been a dream for many, many years, multi-layer, multi-vendor management. But the industry's progressed quite a bit in this area as well. And when we think about the 400 gig pluggable era and moving to the 800 gig pluggable era, we've moved the needle on the network management. So that, to me, is an enabler for more or a quicker adoption of 800 gig pluggables than what we did see for the 400 gig community. And then the standards efforts are moving along to keep pace. So, there are some challenges to overcome. When we think about some of these more innovative concepts, it is going to impact organizations a little bit. When we think about organizations, if we had silo organizations, the IP group, the optical group, do they need to evolve? And we are seeing organizations that are a little more agile there, and they are moving a little bit quicker. So I would, guide folks to looking at some of those types of organizations. And then what is the new demarcation point? We always had a classic demarcation point between the router and the optics, but if the optics is now inside the router, it creates something that needs to be worked through and solved. And then, if we think about some of the more open environments, we may have to come up with some new business models. Who pays whom for what type of thing? And then moving to a much more cloud-like environment, particularly for wavelengths. So wavelengths, when we speak about wavelengths, today we're thinking about 100 gig wavelengths. 400 gig wavelengths are coming quite quickly on the heels of 100 gig wavelengths. There are some providers around the globe that have cited some very large numbers in terms of their wavelength business that they have active today. And there are many folks that are talking about moving to, more of a cloud-like model. And, no one carrier is an island, so there are a few more things to work through in that environment. Inter-carrier federation, we have to be able to hand these wavelengths off from one carrier to another to complete demands for some of the customers. So yeah, there's more coming there. And then the vertical use cases have been touched on, so I won't belabor these, just kind of top and tail a little bit. Business continuity, from my perspective, this is a great use case. One of the things that appeals to me about this is if you can extend the distance. And there's a few reasons why extending the distance is really attractive. Think about some of the larger expensive cities. If you can get outside those more expensive cities, the land is cheaper. You might be able to move on to a different power grid, which is a real benefit these days, being diverse in that sense. And then there's also kind of the standard, the geophysical, so seismic floodplains and whatnot. So if you can take that distance a little bit further, there's a value there, and the APAN can help with higher capacity. And then just a little bit of top and tail on the remote broadcasting case. This one for me goes to the optical capillarity. We have different sites that are not fibered up, so how can you economically fiber them up and put those resources there so that you can have that? But then again, if these are temporal kinds of operations, you might not necessarily, want a circuit up there all the time. You might want to take it up and take it down. So having that agility will be an appeal as well. And then kind of coming back to the network attributes and adding a few cartoons, if you'll tolerate. But the agility is a key thing with wavelength switching, optical capillarity. The graphic is both the actual data up to 2024. So this is optical port shipment by the maximum port speed. So these are all the port speeds that are with us today. 100, 400. We're quite bullish on the 800 gig coming, and due, quite strongly to the pluggables that are just about with us. And then we do have the 1.2T, 1.6T embedded, and this chart is done by the maximum bandwidth. So you can see the type of petabits that we're expecting. And we do have the standard kind of growth trajectory, but then we've factored in what we believe is a reasonable uplift based on the AI phenomena. We're, as analysts, we take in the positive messages, but there's always, reality. I mean, when folks are undertaking these large-scale builds, supply chain has become a huge topic these days. So any kind of supply chain difficulties can slow this down. Just the acquisition of the land, the power, we believe is ultimately going to be a gating factor. So, we do take in all the enthusiasm, but then we temper it and develop our view of what the future is going to look like going forward. And just kind of bringing it back to the stakeholder community. So, from the consumer side, consumers are looking at information, commerce, education, entertainment. When we look at the next generation, they're always super quick to adopt anything new, and the expectations are heightened. So consumers are becoming more savvy on latency. Enterprises are becoming a lot more savvy on things like latency and even jitter. So one of the things that we're going to see is more of the optical parameters, flowing right through and giving the enterprises the visibility of these types of things. We've also heard some quite interesting things, from the cloud community. They would like visibility into carrier networks. What is the inventory that's sitting there? We have multiple providers. What is the actual inventory? They want to see that, in a digital way, and so then they can make rapid decisions to expand capacity. So I think we're going to see more of those types of things. And then government, many agenda items from a government perspective, healthcare, sustainability, again, safety, equitability, and the IOWN will push all of this forward with this industry collaboration, foundational innovation, and commitment to see it through. So just to conclude, we're quite excited about the vision and delivering the value for the stakeholder community. And there's a little bit more work to be done. And we've just done a brief white paper that is just up on the IOWN site, and folks can take a look at that and download that at your leisure. So thank you for listening.
Thank you, Ian. Good job. All right, thank you, Ian, and thank you for that insight and external view and for validating the work that the IOWN Global Forum is doing. So thanks for that. All right, we now have a break until about 3:50. So please go outside, enjoy the exhibits, and interact with some of the exhibitors. We'll be back in here for 2 panel sessions. I earlier said that we were done at 4:30. We'll be done at 5, but we'll still have a networking event at the end. So please enjoy the exhibits and come back for 3:50, and see you then. Thanks. Thank you, everyone, for coming back and joining us for the final 2 panels. And I will just introduce the panel moderator, and he will take it over from there. So let's give a hand to Levan Levroux from Nokia. Levan, over to you.
Okay, technology. Hello, welcome everybody, appreciate it. Before we start and I introduce the panel members, I would like you to get your mobile phone ready because we're going to do an online poll a couple of times where you have to scan and QR tag. You're going to select one, please, and then you press send and we will see it moving. It's the first time I'm doing it, so we'll see how that pans out. So my name is Lieven. I was already introduced. I'm the Vice Chair of the Technical Steering Committee for the IOWN Global Forum. We have Sugiyama-san on our... Yep.
I'm Haida Sugiyama, I'm the Chief Architect of Red Hat and the alternate board director of the IOWN Global Forum. I'm very excited to discuss
Yes.
How the forum drive energy efficiency and sustainability. Yeah.
I'm very excited as well. And then Eric, maybe just again to introduce for the people that potentially weren't here.
Yes, so Eric Hardware from Orange. I lead the research on networks and infrastructures, and I'm also a member of the board of directors of the IOWN Global Forum.
Thank you very much. So I just wanted to set the scene a bit, see if this works, yes. So IOWN, and we have been working, we have a task force that looked at energy efficiency and sustainability. Eric already used the word holistic in his presentation, and I just wanted to reiterate it as well. So we are having a holistic view analysis on how energy can be saved, sustainability can be done over the reference framework that you can see there. Very quickly, we want to look, maybe we won't get there in the first phase, but we do want to look at the applications, where you launch the applications, can we optimize the applications, the data centers design, data center interconnect, the data center fabric. I think we should have we should dare to look at the communication protocols, the stacking of the protocols. Protocol bloating comes to mind. Can we avoid it? And then we go down to the system level, the network element, how you route the traffic and the component level. So you can see that energy efficiency should not be a single thing. Now, let me ask the first question to the team is that, so your organizations have made some quite bold commitments towards sustainability. So how does your respective strategies differ or align when it comes to aligning for the net zero emission for 2024? Eric, do you want to pick that one up?
Yep. So as I mentioned in my introduction message, we have taken the commitment to be net zero by 2040 with some intermediate milestones. So there is one in 2025 that we will pass, I can say it already. And there is another one in 2030, which remains challenging. And we have basically three types of actions in order to meet these objectives. The first one is to be more efficient. So we try to reduce the amount of CO2 emissions. And for that, we want, of course, to rely on technology improvements to be more energy efficient. We want also to extend, as I mentioned during my earlier message, the lifetime of our equipment to reduce the CO2 emission, which is embedded inside the equipments. And for that, we have defined a program of circular economy. So the equipment that we don't use anymore, we put it on the marketplace, we sell it again so that it continues to be used by others, and by doing that, we reduce our CO2 emissions. So that's the first thing, being more efficient. The second thing is decarbonizing our emissions. So for that, we have signed some what we call power purchase agreements. So basically, we sign contracts with electricity providers, long-term contracts that guarantee some level of renewable energy as part for the years to come. And I think that Red Hat has adopted similar approaches. We also rely on solar energy wherever we can. As you may know, we have operation in Africa and Middle East, where the conditions are very favorable for solar energy. And the last part is to have our customers engaged in being themselves careful about the impact they have on our CO2 emissions. And for that, we have a program of selling refurbished smartphones and to collect also the used smartphones. So in France, we collected more than, I think it's 30% of the smartphones, of the used smartphones of our customers. and then we put them into recycling, or we sell them again if they are in good shapes. So altogether, these are the ways that we are using at the moment to be on our trajectory.
Okay. So that in addition to Eric's answer, because Red Hat is an open source software company, and we are investing in the open source project, such as the Sharing Energy Environment Sustainability Project. Oh, can it? Okay. To develop the methodology, to measure the software energy consumption, and also involving the reduction targets, and also harnessing the power of open source in helping the customer and the partner and the suppliers to meet their goal. Yeah.
Cool, thank you. I think there is already a lot being said. What I liked about this is the circular economy, refurbishing, that looks good, partnership, making sure that it's end-to-end, it's not a single pointy thing. Very good.
If I may add one thing where we differ is that we don't have the same role in the value chain.
Correct.
And you may be familiar with the different scopes of carbon emissions, scope 1, scope 2, scope 3. Scope 1 is direct emissions. It's the fuel we put in the cars when we have fuel-based cars. Scope 2 is the electricity that as such is not carbonized, but that use carbon to be produced in some cases. Scope 3 is all the other indirect emissions. And as part of our scope 3 is all the carbon emissions of our suppliers, like for instance, Red Hat, for some parts, and all the consumptions of our customers when they are using services that we sell to them. And all of this is the scope 3. And this is one of the big challenges because we control how we heat our buildings, how we power our cars, but we don't control how our customers or our providers, they are producing the equipment or using the services that we sell. And that is a big challenge to engage them. APN is one of the reasons, the major reasons why Orange joined the IOWN Global Forum, because we expect that, yes, it will allow us to reduce significantly the power consumption of our fixed network.
Right, okay, cool.
Yeah, and also one of the pain points of the GPU, this is, absolutely agree, and we need to reduce power consumption for the GPU system. That's why we can add the APN technology into that cluster also. And also data center infrastructure is another key point, that we can build a data center infrastructure over all photonic network, to reduce power consumption,
Cool. So the application level doesn't seem to get a lot of votes. So, okay, it's more, so basically the way I would summarize it, it's really the infrastructure in the data center and probably going towards it using APN. Okay.
Can I say
yes,
something?
Absolutely, Eric.
There is one dimension which doesn't appear here, but which is handled by the IOWN Global Forum, and that is extremely important. It's the network digital twin. Because, so I spoke about scope 1, scope 2, scope 3. So about the indirect emissions, half for Orange, half of those indirect emissions that represent 80% of our total carbon emissions. So half of those 80% is about the services that we buy to external companies for the maintenance. So maintenance is extremely expensive. So everything that can help us to automate network management, to anticipate failures, to recover from failures automatically, basically anything that allows us to avoid sending people on site to make the repair will help us a lot towards sustainability.
Thank you, thank you. So digital twins, it's a thing to think about. I will have a question for Sugiyama-san. So Red Hat, your company, plays a critical role in cloud-native infrastructure. So how are open source tools such as Kepler and others help bringing the energy awareness into Kubernetes and container environments?
The Kepler is a Kubernetes-based efficient power level exporter, which makes the power consumption estimation at the processor level and the container level and the Kubernetes pod level. So, and the Kepler architecture is extensible for the both industry and the researcher to develop and integrate the power model. So, for example, that maybe the researcher can create AI/ML model
for the application deployment to select the most efficient computing node. That is one example. So there are many approaches we can expand based on the Kepler. Yeah.
Thank you. So integrated model power exporter, so it's a measuring
And
exporter.
yeah, and Kepler covered the computing environment. One missing is optical all-photon network layer. That is one of the white space that the IOWN Global Forum focus on, actually. Yeah.
Yes, thank you. Eric, question for you. I'm moving on. The people can still active, 51 votes. I'm very impressed. I'm very happy. Thank you. We have 2 more polls. Eric, question for you. Orange has set a milestone of 45% emission reduction across all scopes by 2030, 5 years. What is the biggest challenge you see in achieving this particular milestone?
So there are several, actually. But probably the largest one is what I was explaining during my talk earlier, is the fact that we need to reduce our carbon emissions, while at the same time we need to have an infrastructure that expands to manage the increasing traffic. So it's a capacity issue. So everything that can help us to be more efficient in absorbing this extra capacity need, while still allowing us to reduce our carbon emissions, is welcome. But that's not the only thing. As you know, we have also operations in Africa. And in Africa, the coverage is still growing. And that's a very good thing for digital inclusion and for bringing technology and coverage of networks where there is no coverage or where the coverage can be improved. But of course, any radio site you add, carbon expands. So we need also to have solutions to help us to deal with this. So that's clearly a challenge. And I'm not even speaking about the explosion of AI in this picture. So this is very challenging. Now, about, I mentioned also the challenge that we have on the fact that a big part of our emissions is actually not our direct emissions, but the ones of our suppliers or our customers. And in order to manage that, we have launched a program towards our suppliers that allow us to, helps us to engage with our suppliers to encourage them to adopt good practices so that they can have similar commitments as us, so that all of us in the value chain, we can together go towards sustainability.
Thank you. Pretty good. I'm impressed that we're doing this. So the next question is for Sugiyama-san. From the infrastructure software perspective, how can dynamic resource control and scaling of technologies like infra-DDS be better integrated across the cloud and the edge deployment?
Yeah, infra-DDS is infrastructure for dynamic device scaling. Actually, this is a joint work with NTT Software Innovation Center and Fujitsu and FTI and IBM Research Ireland and Red Hat. We are now currently proposing this GitHub to the Cloud Native Computing Foundation to accept the upstream. And this DDS helps to create the composite decentralized infrastructure and dynamically attach the PCI card to the CPU host or deactivate from the CPU host. And that means that we can power off the PCI card. For example, the legacy traditional LLM, we need many GPU memory, so mean many GPU cards. But we don't think that we need to run that all GPU card for 24 hours. Maybe half of the number of the GPU card can be shut down. The infrastructure, infra-DDS can help to manage the scale up or scale down the system, while the Kubernetes manages the scale out and scale in for the application deployment. This will be helpful to reduce the power consumption when they don't need the PCI card. Yeah. And this is just, we are starting this dynamic resource control with the data center and within the composite disaggregated infrastructure and within the Kubernetes cluster. And the answer to your question, actually, first we have to focus on within the data center. But once we complete, we expand this project to the multi-cluster management, because the CNAC already have the multi-cluster management project. And Yes, and another missing feature is that the data, the metric. So that's why Kepler is needed. And another important thing is we are still missing the technology using the all-photon network across multiple data center. That's why we need to work within the IOWN Global Forum to collaborate. Yeah.
I was going to add that, as you know, that we have the capabilities of the network elements to put them in a hibernated, lower power consumption, but the compute layer, the infra DDS, has no knowledge of that, so we need to envision of a controller there. Yes, fully agree with that. One question, and that's not a promise, question for Eric. Orange operates in massive scale across networks and data centers. Where do you see the biggest opportunity for reducing energy consumption? It might be a repeat, but that's fine. Network protocols, equipment, data center operations, one of the topics of our holistic approach, perhaps.
Well, the first thing is that it is so challenging to be net zero that we need to do absolutely everything we can. So all those directions need to be investigated. That's the first thing. Then the best way to save energy is not to consume it, right? So turning off everything that can be shut down is also a very good way. This is something that we are doing more and more on the RAN, on the radio access network for the mobile networks. This is something which is being investigated also from the fixed networks, and this is something that we are strongly supporting. And then the other challenge is the one I was referring to before. It's about maintenance, providing the right tools. And we have a lot of promising tools using AI, for instance, and network digital twins to remove this part of the need to send humans to solve the problems.
Absolutely.
This is where we saw the main benefits.
Benefits, yes, I agree. So we go to the next poll question. What do you consider? Let me flash that up, and hopefully it's here you have to take your telephone out, take a picture of that QR code. And the question is, what do you consider the most promising method for reducing greenhouse gas emissions? And there is increased. So if you please go ahead, hopefully it's going to work the same way. You do need to press send, which I always forgot to do. Increased use of renewable energy, dynamic resource control and scaling, enhanced observability and monitoring. Ties a bit into the digital twin. Protocol and stack simplifications, device level shutdown, hibernation of mechanisms such as infra DDS. Okay, let's just let the answers come in. People give them a little bit of time. It seems like the digital twin increased. Yeah, the passcode is. I'm not going to say it again. I refuse. Interesting. So let's go to 2025 that we have a good sample number. So somebody typed AI. Reducing greenhouse gas emission, and AI is the answer. Okay, potentially. So digital twin seems to be the passcode, increased reusable energy, more hydropower, wind, so more alternative energy, yeah? So with that,
how's nuclear being looked at in
but it's probably the fusion, not the fission. Yes, I think so. So, Yamazan, do you want to give, what do you think about this? Assuming it's the passcode, which is obviously bogus, increased reusable energy seems to be one, renewable energy?
Actually, the increased renewable energy is a common approach that everybody try to do. But in addition to that, they are missing that how we can adapt all photon network technology to reduce the power consumption across the computing layer and the network layer. Because when we discuss sustainability in the CNCF, it's a computing foundation. No one talk about network, actually. That is the current situation. So we need promote advantage of the all photonic network technology, in order to do, probably we need an evaluation tool. Maybe network density twin is one of the way, actually, but we need step by step. First, we need to make a common metric across the computing layer and the network layer.
But do we believe optical networks are going to be a big use of power? I don't think that will be.
Yeah.
No, but it's a solution, I think, what Sugiyama said.
It's not gonna say- If you look at the number, the power consumption of an optical network, the capacity it's driving, it's very low compared to when you compare to GPUs and servers and storage. And
Yeah,
that mindset.
I mean, I'm not saying that not just wider area network, including data center network like a GPU clustering. This is also, we need transform from the electric to the photonic. That means now some of the member already developed the photonic electric combustion chip. That's also, that kind of technology also need adapt in the computing layer. But when we measure that power consumption, it's not easy, actually. So we need to find a way to make a common metric. Yeah.
Yes, the common metric is a key word. We will come back to that later. Eric, what is your view on this?
Yeah, I mean, I find there are several words I use myself, so I cannot disagree. I think that I see also quantum computing, and I think quantum computing, when it will be ready, then will be also a good solution to considerably accelerate some computation with a much lower energy consumption, but it's not there today.
It's not there, yeah. I'm going to give the person that says small nuclear power plant a beer tonight, so please come to me. So the question is, what should be the top priority to reach net zero carbon in 2040? Standardization of energy efficiency technologies was one option. Scaling adoption of IOWN technologies, to Sugiyama-san's point. Public-private collaboration and commitments. Continuous real-time carbon footprint monitoring and accelerated deployment of green data centers. Now, unfortunately, you can't vote. My apologies. That's an error from our part. But let's say the top priority net zero carbon 2040. Excuse me. Any thoughts on that? Sugiyama-san or Eric? Yeah, it's the token, the hot potato routing. You wanna see the question, or you're fine?
Yeah, I think that as I said, I mean, we need to do everything because it's very, as I said, we will pass the 2025 milestone in orange. 2030 is more challenging. It is extremely challenging. So every effort is needed. Everything we can do, every trigger we can pull, we need to do it.
Yes.
Yeah, I agree with you. And but especially as a software vendor, I mean, continuous real-time carbon footprint monitoring is really important to produce in the market. So everybody feels that we need to reduce power consumption. And so yeah, and of course we need everything. Actually, we need to
option F.
Parallelly, yeah.
All of the above.
Yeah. Option F.
Yeah, I should have added that. Sorry. Yeah. I'm just going to, and then I'll take. I think we have some more time, and I'll take some questions from the floor. Can I get the next slide, please? I just wanted to show that we are. And one more, please. Yeah, that one. Thank you. So basically, we started off with the holistic approach and what we did, or what our approach is with the different points that you've seen. It was a kind of mantra, what is important on each individual point. What we wanted to say is that the work that we've done in IOWN Global Forum is that we have already the first released document, which is the driving efficiency and sustainability. It's an introduction document, so to speak. It's like, from our vantage points, what do we see, where are the gaps? One of the things that I think is a gap, it's not listed here, but is per tenancy power consumption. So per tenant company or an enterprise that is connected to an APN should be able to read and receive the power consumption they have for their connectivity services. So you can see what we're trying to do more. We are going to reach out to standards bodies and SDOs to get their view. It's a broken mantra perhaps, but IOWN is in a very unique position we are the glue between all the different standards bodies, so that's the power, hence the reason we're going to reach out. I will take any questions from the floor if there are any. Yeah, Gio, you probably have 1,000 questions. One would be very good. The mic is there.
Anybody have a question?
It's very difficult to see with the backlight. Oh, there is a question. Yeah, please.
I was hearing that targeting 2040 for net zero, I think, is extremely challenging. Most of the high scaler asking for 2050 maybe is achievable. Why we cannot really change, rather than achieving net zero, is just putting, let's say, reducing by 80%, 90%, 95%, I think, setting like achievable goals rather than really shooting for net zero, which I think is unachievable somehow.
Right. So can I turn it around into a question? You're saying, what I heard is that you don't think it's achievable to go to zero, but we should aim to go to zero.
Correct.
And it should be more achievable if we don't go and shoot for the top prize, but go as fast as we can.
Step by step.
Step by step.
Exactly.
Okay, cool. Eric.
Yeah, maybe it's good that we clarify what we mean by net zero. Net zero doesn't mean zero.
Right.
And so in orange, and that was one of the charts I shown in my earlier talk, which is the orange path towards net zero. Actually, we know there will be always some carbon emissions, whatever you do. So our plan is to reduce our carbon emissions by 90% in 2040, and the rest we will compensate by carbon sinks, like planting mangroves, that kind of thing. But of course, the earth cannot be covered with mangroves. So it means that you cannot just compensate everything we do today. The volume of carbon emissions today is not compensable. Yeah? So that means that the first thing you need to do is to reduce as much as you can. And then the remaining part will be, you will be able to compensate it in a realistic way. That is the philosophy.
Thank you.
Thank you. Any other questions? I do have one. So looking ahead, what excites you most about the potential of IOWN Global Forum technologies, architectures in shaping a more sustainable digital world? Siguyama-san, do you want to start? Sorry.
Yeah, I mean, I think that what we do in the IOWN Global Forum is very relevant when it comes to energy consumption, because we address networks and computing. And those two together is really what is, at the moment, accelerating the CO2 emissions, or what we fear will considerably increase the carbon emissions, especially because of these AI explosions and all the new data centers being built. So addressing those two dimensions is very relevant to address this problem.
Yeah, I'm thinking that IOWN Global Forum is only the committee worldwide to discuss the computing layer, through the computing layer and packet layer and all photonic network layer. This is only the way to reduce real power consumption in the IT technology, with IT technology, actually. Yeah, that's I'm expecting to accelerate this activity in the IOWN Global Forum. Yeah.
Thank you very much. I just want to say, I hope you enjoyed this little interludium with energy efficiency and the polls. I hope the polls made some things clearer for you all. I would also call out for action if you want to join us, and if you're emotional about it, passionate about this, or hey, you think it's necessary, please reach out. We're happy to accommodate any of your efforts to help IOWN, and especially the energy efficiency globally, a greener, less warmer, less stormy, less a better place, in short. Thank you very much. I want to thank my panels, my dear friends, for this. If you have any other questions, please reach out. Thank you. Vito, back to you.
Thank you very much, Leeman, for that topic. I know it's something very close to your heart and important to the IOWN Global Forum. And thank you for being a pioneer with new technologies. Well, I'm sure it's going to get better, but somebody always has to go first. So thank you for that. All right, now we're going to close out with a bang and the final panel here. And I will introduce the panel moderator, who will introduce himself further, as well as the rest of the panel's members. So please join me in welcoming Supantha to the stage. Thank you.
Thank you, Vito. Good afternoon. Today we are going to talk about our panel, Delivering Tomorrow's Infrastructure. We are going to talk about AI, APN, GPU, DC, with a little dose of humor and less acronyms. We have brought together some of the top minds from this industry for this panel. Let me welcome our first guest, Jefferson Wang. He's the Chief Strategy Officer of Accenture Cloud First. One interesting thing about him, he leads the unit of Accenture that brings in $32 billion of revenue every year. And if you want to get his attention or get him to convince for a deal, I have a tip. Get him a sugar or a dessert, and he's all yours.
It's true. A huge sweet tooth.
And the next one is Stéphane Lassard, all the way from Canada. He's the key member of System Photonics research team at Ericsson. And one interesting thing about him, he's more like a hunter-gatherer. He loves to go to the woods, grab fish from the river. The mushrooms, brings his own wine, and eats everything out of the nature. So if there's an apocalypse tomorrow, I know who I'm going to follow.
You're welcome.
Next, very own from our Sweden, Mats Granryd. He's the chairman of Business Sweden, former director general of GSMA, and former CEO of Tele2. He has always had a telecom hat, but one thing he's more passionate about is dishwashers. The one that's in your house, he feels sorry for the dishwasher because he thinks we take out all the clean dishes out of it and then immediately put new things, new dirty things in it again. It's not very nice for us of humans to do that. Poor dishwasher. And last is Ito-san, IOWN's Global Forum Chair of Use Case, a distinguished Sony engineer, and the head of technical laboratory at Lund University in Sweden. And he travels quite a bit, like every month between Sweden and Japan. And the reason is that he coaches 2 rugby teams in Japan, and you won't miss it for anything. And that's my panel. I'll start with you, Mats, for our first thing.
Okay.
You have led telecom companies, telecom associations, and you are in Sweden, which pioneered a lot of these telecom technologies. How do you see the network infrastructure being revolutionized through contributions from Sweden?
Well, I mean, I need to clarify my dishwashing sort of passion. I really feel sorry for the dishwasher when you have filled it up with dirty dishes, it doesn't work, and then you immediately take it out and then you fill it up again. I mean, the poor thing is never clean. So that's what I was thinking about. But I think that the network contribution that Sweden has done has largely been up to a private-public partnership that was established back in the 80s or 70s called LMTEL. That was between Ericsson and the state-owned monopoly Telia at that time. It was called different. But that joint venture developed the first AXE switch. And the AXE switch was the switch, if you would like, of all take all telephony fixed and then became mobile as well. That was the start of it. And I think it is quite interesting to see that little partnership grew into world-leading businesses such as Ericsson and Telia to some extent. Now, of course, we have Nokia here as well, which is another fantastic supplier of network equipment. I wouldn't exaggerate Sweden's role going forward, but certainly Ericsson and Nokia has developed a breeding ground of good innovative climate, good innovative companies that are mushrooming everywhere. And you would find that Sweden and maybe Stockholm and Lund possibly as well is some places where the entrepreneurs are really very strong and doing a lot of innovative work.
Amazing. Sweden does have a lot of countries, including one of the founder members for GSMA.
Yeah, absolutely. Yeah. And we have Spotify, and we have Klarna, and we have a whole bunch of other companies that have come up now lately as well.
And I now go to Ericsson's Stefan. You do research in photonics. That's one of the conference topics are. Mm-hmm. So what is the most important developments that's happening in photonics that you are working on?
Well, photonics is, we're comparing, the RAN network, the entire ecosystem to a Ferrari yesterday with some private discussions. And we're saying, of course you have the beauty of the RAN complexity, that's actually the actual car. But, it looks like really not too much, but the tires are important to go somewhere. And the optical in the entire mobile environment is what actually keeps the whole thing holding together. If you don't have optical, I mean, you cannot get the traffic in and out of your RAN. So, and it drives a lot of things. It drives your capacity to scale up. So you need the capacity of the optical, but you also need the optical, the power savings that optical will provide you. And it's probably one of the key things that's going to come out soon is what we're working on is the co-packaged optics aspect. The fact that let's say if you take like a large Ethernet switch as a toy model, you can say that 30 to 40% of the energy that the actual switch ASIC will consume will be pure I/O, just getting data in and out, electrical. And the fact is, I mean, it comes with, you have billions of transistors and analog components dedicated to this, and it consumes, hundreds of watts. When you go optical, you can definitely scale that down to a lot because you go from having to drive electrical signal that consume a lot of power in terms of driving it, but also in terms of processing to make the signal survive a certain distance over a certain electrical physical channel to a few millimeters. So then you send the electrical signal over a few millimeters, and then you can drive 5, 10, 500, 1 kilometer directly from your ASIC if you need to. So it opens up not only power savings, but a whole new design of system because you can start to delocalize parts of the system and rethink the whole optimization of your design and of your offering.
Energy saving, of course, is one of the main topics we'll address more in details. But let's broaden it outside of Sweden and go to more on global level. And Jeff, we used to think infrastructure meant roads and bridges. Now it's fiber optics and server farms and a huge scale. When did our highways get digital and who's driving really?
Yeah, it's really important to kind of baseline the definition, right? That digital infrastructure now is network connectivity. It's compute, where actual things are processed. It's the storage and it's security wrapped around it. So if we kind of start with that as the baseline of digital infrastructure, then we kind of look at the big trends that are affecting it globally, right? So you can't trip at a conference without a conversation on AI right now, but the ability to actually enable the AI requires digital infrastructure. The ability to actually automate some of these decisions and transform industries, whether it's on the B2B side or the B2C side, requires digital infrastructure. So I think that's super important to really think about, what's the baseline definition of digital infrastructure, the importance of the enablers to it, and ultimately what we can build on top of it.
That's quite intriguing. I will come back to you after coming to Ito-san. And you are part of IOWN, you head the use case chair. And what are you currently working on that could lead to the next breakthrough in advanced infrastructure?
Okay. IOWN Global Forum, we have such a diverse membership, so we have multiple use cases that we work on. But in general, the common denominator for this use case is that you have the physical world, you get the data, you transport to the compute, then you process it, then you feed back to the physical world. So you have an entire cycle of this. You need to transport, you need the compute, and you need another transport to bring it back to physical. That has to be real time. So what is the constraint right now is, to me, is a compute part. The reason, in order to make this the compute or the end-to-end real time, you want the compute resource to be closer to the people, closer to the physical. But you just can't do it because you need another electricity for the data center. You need the water to cool down the data center. If it coexists with where the people is, simply you're not able to do it. But if the optics, if it's capable to push this data center away from where the people is, then it suddenly becomes feasible that you'll be able to do this in an economical, rational way. So then real time can be done. Now, if you can push this back to the outside of the city, then if you can distribute it, then it becomes now scalable in a way. If you just add the data center, if you need a compute resource, it becomes a scalable application. Again, it will lead to the sustainable or the sustainable infrastructure. And in addition to that, relating to the previous discussion in the energy efficiency part, if you can distribute the data center, you'll be able to use the renewable energy. Then again, it becomes more economically rational. So to me, it's really about enabling the distributed data center that gives this new cycle. And the next generation infrastructure, I'm really hoping this distributed data center concept will come in play.
It connects to like what Jefferson said. Like, Jeff, how is advanced connectivity helping industries to go from like doing more with less to doing things that we don't even know that it existed?
Yeah, I mean, let's start in kind of chapters to this story, right? Ito-san mentioned a really good one that right now, what can we do to change a value chain, right? Something that's limited. If we can't put, latency is basically defined by physical distance. So if we can't find the actual real estate and we go further, you have to make up that physical distance with a low latency network on APN. That makes a lot of sense as a starting point. If we kind of look at some of the other use cases that we are thinking about, when you look at, take a value chain like media, right? So right now, I think everybody would be surprised at this, but a lot of the clients we work with at Accenture on the media side physically take the content and drive it to the other side of town so that it can go through post-production. Or at a sporting event, there's always a big van that's next to exactly where the content is happening because they're doing post-production and then shipping it back out. All of that can be changed when you have a network like an APN, for example, right? You don't need to physically drive it. You can actually transport it differently. So media on broadcast can be changed. If you look at one step further, when you think about, I think Levin's slide at the very top had digital twins. When you think about digital twins, the really good part of it is you're doing what-if scenario planning on a digital twin, so you don't have to physically do it and learn as you go. But the challenge with digital twin is the adoption and the performance of it. So like any good application, when it can't perform, you generally don't want to operate with it anymore. And digital twin is a very compute-heavy scenario. And in the future, we're going to have digital twins interacting with each other. If you go into an agentic framework and you have agents operating to solve problems, digital twins are going to actually interact with each other. That's an incredibly compute-heavy situation, something that we can't do today. And then if you go one more step further in the horizon, quantum safe security, right? What can you do with an APN network so that you can actually make things quantum safe? A lot of times we fear a lot with those quantum keys and those RSA keys being melted because of quantum. How do we create this next layer of security on those? So I think it's super interesting when you kind of take the steps and look at the horizons of what's possible with this.
That brings to this APN-based networks. Stefan, like APN has the potential to reduce energy consumption in data centers dramatically. But how big of a game changer is this? And what is holding us back from a wider adoption?
Well, you can have a certain level of adoption today. The ecosystem is actually getting there. The fact is, you need to have a rethinking and a redesign of your network if you want to implement fully all the benefits of APN. And I remember, I mean, we talked about the like an example is and it's funny, we had this discussion yesterday with the mobile edge compute, where one of the use case that Kagoshima-san was showing, you had like 2 mobile edge clouds, basically, let's say north and south of a metro area. And the idea was to, how about because we have challenges with the mobile edge clouds, how can we replace that by an optimized, all photonics network path through the network? Well, there's a lot of technical things that happen there with all the subcomponents of APN that needs to be in place and fully mature before you can actually claim the replacement of a physical, let's say, location optimized mobile edge cloud. And you can make a prototype of it, but to make it as a commercial offering, there's still, a certain level of maturity to gain there. And just to go back for a second to IOWN. I mean, IOWN is very good for something like this because it's driven from use cases. It's been explained earlier by other presenters, but it's explained by use cases, and it percolates down to technology. And at every step of the way, you have a message you can send out to the ecosystem into what's coming, what's needed, and how to adopt it. And if it's properly done, then you can probably accelerate the adoption of that kind of infrastructure. And the fact that we have operators being part of this, which is not like, you don't have operators. I was at OIF last week for a new link speed for AI. Of course, it's something that's going to happen within your printed circuit board. The operators are not there. But in IOWN, the operators are here. And they see, and they know, and they can give you immediate feedback on what's needed. So that helps to have kind of a self-coherent system where you don't have the usual technology percolation that's much slower. So yes, it can definitely happen faster if things are put in place.
Okay. I would want to get into mobile edge computing, but before that, I would want your thoughts on it, Ito-san. What do you think?
I just wanted to pose a question that earlier this session that we talked about taking a risk when you want to bring in the innovation. The concept of this all-photonic network, or the distributed computing, in fact, it's really not easy to do step by step. You need to really change entire components or entire ecosystem in order to make this available. And there's a huge gap still. It's not really about the technology, I don't think. It's really about how do you transform this. And I mean, if you can jump it, yes, that's possible. How do you really transform it gradually so it is really feasible? I think Eric talked about it, that you need to do everything. That's exactly the case. So although it's doable, how does it really make sense to do it like this?
That's an excellent point. It's more a revolution than an evolution. That's the thing. You need to have many things ready in place when you want to do that, big step all at once to get all the benefits. So that's why it's a bit more special than just the natural evolution of the network and the subcomponents and this.
Talking about evolution, what do you think is happening with mobile edge computing, man? It has been talked about for a decade or more.
Yeah, no, but I mean, mobile edge computing is there, and it is happening. I mean, you have cars driving half automatic. That's edge computing. They can never be completely reliable or being connected all the time, so they need to have their own computing power. You have street furniture being also on edge computing, so it's certainly happening. So I don't think that's a major issue. Latency is a major issue, definitely. 5G will help, and once we start to deploy 5G standalone, which sadly the industry is very weak on doing, I think it's sort of 20% or so of mobile operators so far have deployed standalone. A whopping 85% of mobile operators, when we ask mobile operators, say that they will deploy 5G Advanced, which is standalone as part of that, in 2 years' time. I think that's grossly overestimated. And I would say a word of caution of having this revolution, being part of this industry for many, many years, that is seldom a success. It has to be a path where you slowly but surely grow into something. jumping onto a new bandwagon. We saw SMRs, so small modular reactors, as one of the energy things up here. That's also heavily debated. It still doesn't exist. In Canada, you're building the first one, but it's still not existing. And I know that many energy utility companies are a bit afraid of going into this sort of new technology, even though boiling water is a very well-known technology. This is just a housing, but just the house itself is complicated enough. So a word of caution on that, definitely.
Talking about mobile edge computing, Stefan, isn't photonics the invisible enabler that makes it all possible?
Well, yeah, absolutely. I mean, it's not something that can exist without a proper physical photonic layer. So it's the, well, of course, I can say I'm a photonics guy. I'm going to tell you it's the absolute enabler, but it's not only the absolute enabler. It's a partial enabler. I think you need, it's another thing where you also need to have just enough components or benefits from photonics in place for it to happen at the price point and at the deployment and easiness that you would expect. And maybe it's not totally fully there, because the mobile edge compute clouds, when you look at how they're built, they're architectured, they're basically more or less miniature versions with some what I call anisotropy for east-west, for some optimized applications compared to like a tier 1 exascale data center. So yes, it's there, but it reuses some of that technology. I think you need to have probably some more optimized, and we can think of an example that we had in the past at Ericsson was maybe just too early, but the HGSA 8000 that had this fully optical backplane without pluggables that was consuming less power and had this linear scaling factor. That's the kind of things that need to be considered if you want to have like a fully optimized mobile edge compute that can potentially be more, I would say, friendly to deploy, because probably less power consuming, for instance.
I think it's also like the definition of where edge is really important, and that's probably where a technology innovation can help, right? I mean, the holy trinity of innovation is generally, is there a tech innovation, is there a business model innovation, or is there an ecosystem innovation? But when you look at kind of what IOWN can provide, there's clearly a tech innovation that can change this a little bit. So, I mean, we have clients that basically have asked us, we want to air gap this, and we want to have the edge on-prem, and we want to basically keep the data on-prem and keep everything on-prem, in which case it's near real time. And then there's a cost associated to that. But if there is an all-photonic layer, can we move that edge maybe to a carrier data center? Can we move it to somewhere offsite? But could it still be serving the purpose, but now you've taken some of the cost out of it? Or ultimately, could you put it further, right? So I mean, I think, from a macro tower out to on-site, there's a lot of definition around now with a tech innovation like IOWN, you can change that definition of edge a little bit, and that changes the business model curve too, to what Stefan is saying. So when you kind of get two of those components on true innovation, when you have a tech innovation like a photonic layer that doesn't have electronics, and then you have a business model innovation because now you've taken some cost out of the system, now you can start to move, right? Whereas before it was always sort of really rigid on that. And to Mats's point, I think it's the use cases are there. There's a need for it, and now it's our job to make it easier.
Yeah. Staying with you, Jeff, as a global organization, how do you balance this tech progress with the geopolitical situation, with tariffs and other things? How do you balance that?
It's a really volatile time right now, and I think when we were prepping on this, there's so many implications to this. When we just look at tariffs, right, we kind of view it in a couple phases, right? Right now, there's the Rose Garden announcement, there's the retaliation, there's the negotiation, and then there's the many years of impact that we're gonna have to figure out. And that equates to a long period of volatility. And when you think about how important, what we first said is, if you agree with the thesis that the digital infrastructure is the absolute foundation to AI, to cloud, to innovation, then you have to get into the geopolitics of this. Because right now, we're starting to see tech silos happen, where a lot of the US tech is now kind of looked upon as, we want sovereignty in Europe, so the US techs have a situation. India is building their own cloud. China has been separated from US for a long time, and it's only getting worse now with 150 to 200% tariffs. So you're starting to see these kind of tech silos. But Mats, I mean, you see this globally. I mean, there's lots of implications.
Oh, there's huge. I mean, if you just take standardization, 5G, 4G, 3G, 2G was all built on having a common standard. The bigger it is, once we moved out of 3G, which was a mess with all these different standards, into a common 4G, and now with 5G, all of a sudden we got scale. All of a sudden we got an opportunity to invest properly in equipment, in handsets, in applications that were universally workable. So I get allergic when I see 6G, because in my world, it is not the generational shift that we're seeing. What is happening, what I think we should talk about, is that today we're in release 18, and next year will be 19, and then 20, and then release 21, and release 21 would be sort of close to what we say 6G. But let's not talk about that. Let's talk about release 21, and then there will be a release 22. So it will become an automatic activity. I mean, if we're sitting with our broadband at home, we don't know what technology is. Many don't know if it's fiber or cable, is it DOCSIS 3 or phantoming. We don't care. It works. It gives me what I need. That's sort of where I think the mobile industry will go. If we start to push 6G, the risk is multifold because of this technological divide that might happen, and we might end up in a fragmented standardization environment, and we're back then to pre-2003 or so, when we have different standards, plus the fact that we are nowhere close of utilizing or making use of all the benefits from 5G. We're nowhere close to do that. We haven't even deployed standalone. And we're just moving into 5G advanced. Let's stay in this environment for many more years and stop talking about 6G, but into release handling, like any other mature industry. That would be, yeah, and if we don't, then we're back to exactly what you said, Jeff.
I agree, absolutely. This is like a separate topic on its own. But coming back to photonics, Ito-san, so what are some real-world applications of photonics we are seeing today, like beyond speeding up Netflix?
Netflix. Okay. No, I mean, again, we have all the use cases, 22, 26 use cases that we have been discussing in the IOWN Global Forum. But again, interactive is what is the commonality. I mean, it's not just one-way data transfer. It's really interacting with the real and interacting with the virtual, interacting with between people to people, and try to get out of the constraint of being distant, that is. So it's any interactive application, if you can, with the photonics, technically, we know we can do it. It's really the matter of, can you do it with economically rational manner? That's why we need this data center distributed. We need some green energy component in, and of course the scale of the business needs to be in. But low latency, computing power, scalability, all these components is what we've been talking about, I believe. So.
We have a lot of questions, but we're really running out of time, so I will just go for the short answers today. Jeff, like, what's the most overhyped tech buzzword, and what should we replace it with?
Overhyped tech, AI, and replace it with applied automated intelligence.
That's a good one. Stephen, say you have a crystal ball. What is the boldest prediction for, say, 2030 for you?
In optics?
Yep.
Oh, geez. I think you're going to see a democratization of the AI processing through the advent of new packaging and new interconnect technologies out of optical. That's going to simplify many things, consume less power, and it's going to enable more parallelization, simpler designs, and less strain on cooling, for instance. So I think from the optical, I would say applied optical side, that's probably one of these. Because on the other side, if you look at the telecom systems, I mean, we have the technologies, it's going to follow the usual path. But on that perspective, I think this is really one of the big revolutions going to happen.
Great. Matt, you have always been an infrastructure builder. Say somebody gives you EU gives you a blank check to invest anywhere to build infrastructure. where will you go?
Well, I think that one of the biggest issues we have as a planet is that we are seeing a world that is not equal. Today, 60% of us use mobile internet. 60%. That's 4.2 billion. 37% are living beneath a mobile broadband coverage. So that's 3G, 4G, or 5G. They live beneath a mobile, so they could connect to mobile broadband, but they don't. And then you have sort of 2% or thereabouts that do not have any infrastructure. They cannot. There's no coverage. That's 300 million. So 300 million people. So satellites, for instance, that's perfect. You go after the 300 million. That's what really needs. However, we have the big chunk of 3.1, 3.2 billion people. That's 40% of the world's population living beneath the mobile broadband, but they don't use it. And we know why. It's affordability of handsets. It is concerns around data security and safety. It is no local content. And it's digital skills. So if I would get a huge amount of money, I would go after that. Because that's an easy, low-hanging fruit. There is no more infrastructure needs to be being built out. It's just finding the tools, working with governments, finding a taxation that is amicable for using handsets, smartphones, having a digital education scheme in place, etc., etc. So it's very simple, but it's really very hard. We have done a phenomenal work in building out hardware. We don't need any more hardware. We need now, all of us, to focus on getting people included. Otherwise, we will end up in the world with 60% have everything and 40% have nothing. It would be horrible.
One thing on the last question to you, what is the biggest barrier that is stopping in developing future infrastructure, Ito-san?
Oh, you had to give me that. I thought I was doing very well until now. Now you gave me the big bomb here. What do you think? What do you think?
Biggest barrier?
Yeah.
I think right now, one of the bigger barriers right now is how many permutations there are to technology. And we don't necessarily make it easy. I mean, Matt's described it. It's like, there's a time when I was building smartphones, there was a time where probably everybody in this room, we cared about how many megapixels was on the back of your camera. And that was like the big thing. I was like, oh my God, now I got to double it. Now I get to the 50 megapixels. Now you don't ask the question. You just say, does it take a picture in low light? There's going to be a slope where we actually care about these, and then it's going to be a slope where it's like, okay, is it doing what I need it to? So I think right now, when you look at all photonics, when you look at ION, we're reinventing something. So there's lots of permutations to it. And that's what makes it difficult. Then you have to think about the adoption, the change management, the actual use case. So like when you look at a value chain, you have to collapse the value chain to take actual dollars out of it so that there's an adoption. You have to make sure the performance is good, like that media value chain we talked about, so that people want to use it or change something. But right now, there's so many different permutations. If you've kind of followed what we talked about, edge, I can define edge wherever I want, but there's trade-offs for each one, and now the enterprise has to think, oh, how do I decide? Is this a cost, is this a performance, or is this a control thing? So we have to almost make it very cookie cutter and basically say, like, here's your 3 options. Let's find success there. Let's rally around that. And then ultimately, we can actually drive permutations. But right now, we're starting with lots of permutations. And that's what I think is the hardest adoption point right now.
Absolutely. Our time is up, but it is so nice to hear that, like, we have a lot of visionaries in our midst. Give a big round of applause to the panelists.
Thank you. Well done.
Okay.
Sorry.
Thank you, guys. Like you said, you did cover a lot of ground, and there were topics in there that could have been a panel just on their own. So thank you for giving us your insights and your expertise. Appreciate that. Okay, we have come to the end of our event, except for our closing remarks. I just want to remind you that we have appetizers and cocktails outside. So after our final speaker, please join us outside of the room here. And so let me introduce Per Bemming from Ericsson to send us off. Thank you, Per. Let's welcome him here. Thank you, Per. Good to see you.
See you. And thank you. And I should be as brief as I possibly can, since it's me between you and the drinks, and that's usually a bad thing to be. But I think we have heard a lot of good things. We have had a lot of inside out in this future session. The forum has presented what we are doing, what we are aiming at, the techno-economic analysis that we are doing, trying to understand the big questions on how to get our technologies that we are looking into actually to be deployed and used. And I think we will try to then get the feedback that we just received on how to think about it, that we cannot maybe not do a big bang all over the place, but have to have a viable path on how to get things out. And that has usually been the case that has been needed in many years. I just want to thank everybody to participated in this Futures event. It is actually here where we design the future of the forum. We're trying to get the feedback, getting the future of maybe new members coming in based on discussions that we have had during these days and this event, and we will take it from there. And with that, I think it's time to go for some exhibitions and the reception. So we have a number of exhibitors that showcase technologies, and we technology geeks like me gonna go have a look in detail. Maybe you can see the photonics if you look really, really close. So please join us. And thanks everybody for a good show.